Good morning, everyone. My name is Jilikita. Today I am explaining my blog, which is based on logistic regression. What is logistic regression? Logistic regression is a machine learning. It is used for classification problem, not prediction of continuous value. The output is binary, usually 0 or 1. Its answer should be yes, no, true, false, pass, fail type questions. Example: email is spam or not spam, student pass or fail, etc. Why it is called regression? Even though it is used for classification, it is used a regression equation internally. It applies a regression formula and then converts the result into probability. Output of logistic regression: output is a probability between 0 and 1. This probability converts into class 0 or 1, usually threshold. Common threshold value is zero point 0.5. Example: probability is greater than and equals to zero point 0.5, class 1 is equals to yes. Probability is smaller than zero point 0.5, class 0, no. Logistic regression formula: it is a graph of logistic regression. We can see a clear difference of logistic regression and linear regression. Linear regression is a straight line graph. Logical regression is a curved and predict y lies within a 0 and 1 range. Logistic regression formula is z is equals to mx plus c. Then apply the symbols function p is equals to 1 upon 1 plus e to the power minus z, where p is equals to probability 0 to 1, z is equals to linear combination of input features, m is equals to weight, c is equals to intercept. Symbol of function: z is equals to 1 upon 1 plus e to the power minus z. This is a formula of symbolic function. This is a graph of logistic regression. This is a code of logistic regression. This is a import necessary library. This is a import necessary library. Import num py as np from sklearn point linear dash model import logistic regression from sklearn point model section import test train test split from sklearn matrix import accuracy score confusion matrix import pandas as pd. Then get a data set, create a synthetic data set. X is equals to np point x is equals to np point 3 point np point array 3.78 2.44 2.09 0.14 1.72 1.65 dash 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 reshape minus 1 or 1. Then y is equals to np dot array 0 0 0 0 0 1 1 1 1 1. Then split the dataset into training and testing set. 80% trained, 20% test. X train, X test, Y train, Y test is equals to train test split X, Y, test size zero point 0.2, random size, random state 0. Create a train the model, train the model. Model is equals to logistic regression, solver is equals to lib linear. Random state is equals to 0. Model dot fit x train y train. Make a prediction. Y predict is equals to model dot predict x text. Then print predict for a 3.4 mm tumor. Predict 0. 0 is equals to no, 1 is equals to yes. Get probability of for a single prediction. Probabilities is equals to model point predict dash probo new data. Probo class 1 predict probabilities 0 1. Print probabilities of beginning cancers. Evaluate the model. Accuracy is equals to accuracy score y test y predict. Confusion matrix is equals to confusion matrix y test comma y predict. Print the model of accuracy test. Then print confusion matrix. Print confo matrix. If name is equals to main, run logistic regression example. This is a basic code of logistic regression. Convert any value into range 0 to 1 has a S-shaped curve. Make logistic regression suitable for a classification. How logistic regression works step by step. Take input data features, multiple features with weight, add bias, apply symbolic function, get probability output, compare with threshold, assign class label or 0 or 1. Types of logistic regression. Binary logistic regression. Two class 0 oblique 1. Multiple logical regression. More than two classes. Ordinary logistic regression. Ordered classes. Advantages of logistic regression. Easy to understand, fast and efficient, give probability output, work well for binary classification, less computational power required. Disadvantage of logistic regression work mainly for linear decision boundaries, not suitable for complex data, sensitive to outer layers, need large data for better accuracy. Logistic regression in machine learning. It is supervised learning algorithm mainly used for classification problem, common baseline model in ML projects.